7. All right. 1997. In an electrolytic cell, a current of 0.25 ampere is passed through a solution of chloride of iron, chloride of iron, producing iron and chlorine. Okay. So is this a single chamber or a double chamber? Single. So it's electrolysis. Also, what you may have overlooked is this word right here, producing, and these things here. That is being produced. You must keep that in mind when answering this question. Producing. In other words, that is what's happening when I run 0.25 amps through this solution of chloride of iron. Me like chloride of iron. A, write the equation for the reaction that occurs at the anode. Well, let's I'm going to write both of these, okay? Both of them. Okay, so A, I have iron that, iron as my product. So looking at your sheet, how do I write this half reaction? No yawning.
Sorry.
Should I do the iron plus 3 goes to iron plus 2?
Oh, I found it. That's
Yes. I do. Okay. Bye. Lucas, G104 right now. G104. All right. So how would I write this reaction? Here, I'll give you a hint. Very good. Thank you, C. Okay. And what is that charge or that voltage? I lost it. Negative 0.44. Okay. And then we have Cl2 is being produced. So how would I write that half reaction? Look near the top, fourth from the top. So 2 Cl negative and 2 electrons. And that has a voltage of negative 1.36. Okay. So I wrote both of those equations out so that you could see. Now, again, I'm not answering the question yet. There's my iron. There's my chlorine that was produced. Okay. Now, A, which one of these am I going to keep? The chlorine. So I'm going to draw a line through his. I'm not erasing it, but I'm going to box this in. That's my answer for A. Okay? Because you're going to need that other equation. It's nice to have it nearby. But be sure to answer the question. How do you answer it? Draw a line through the one and then box in the other. All right. B, when the cell operates for 2 hours, 0.521 gram of iron is deposited at 1 electrode. Determine the formula of the chloride of iron in the original solution. So we have a gram amount again. What should we do? Moles. I like that. So we have 0.521 grams of iron. 1 mole of iron is 55.85. Is that right? Hang on here. Double check. Yep. Okay. And let's see. What else can we do here? Nope. Hours to seconds. Oh, yeah. Here in a second. Let's get this critter first. So 0.521. No, you're good. You're good. I get you. You're working faster than me. 0.009. We'll say 33 moles. All right. Then what'd you say, Jess? I'm sorry. Hours to seconds. Well, that was quick. Did you sprint there?
No, they didn't need it.
Oh my gosh.
They needed Mason Anderson and Lucas West.
That's interesting.
Yeah.
All right. Remember that in 1 hour is probably 1 hour, there's 3,600 seconds. So 2 hours, 7,200. Okay. All right. So we have our time. And what else oh, hello, mama. Okay. So did I say something bad? I don't know.
That was a little too loud.
All right. So now let's get our coulombs. Oh. 0.25. So 1,800 amp seconds. The test back? What quiz?
What quiz? Yeah, we did. No, we didn't. I don't know.
The redox.
Yes. I don't know.
Yeah?
That quiz.
Oh, I think I did.
I think you know. Yeah, I think you did.
All right.
I don't know.
All right, let's continue.
I didn't get it.
So 1,800 coulombs. So 96,485 coulombs. 1 mole of electrons. So that divided by 9,645. Oh, so 0.0187. And that is moles of electrons. So how in the world could we ever figure out what the charge is based on that information? That's right. Take that mole of electrons and divide it by how many moles of iron you have equals, do that mental math, 2. So what's the charge on the iron? Plus 2. Which ironically we had already up here, but that wasn't enough. Okay, so that's just a confirmation. We didn't know that. We didn't know that. So plus 2. Correct. To confirm it. What are you talking about? All right. C says, write the balanced equation for the overall reaction that occurs in the cell. Well, by Gumby, we have all the makings right up here. What? Oh, well, yeah, that would help as well. So since we know that the iron has a plus 2 charge, nope, don't do that. Since we know the iron has a plus 2 charge and chlorine is a -1 charge, balance those charges. Thank you. I did not answer the question.
Yeah, I was confused at the question.
I appreciate your diligence. I was expecting Nick to say something, but
That was a test.
that was a test, yes. All right, letter C. Write the balanced equation. So we have this information here. So Fe plus 2 plus 2 chlorines makes Fe and Cl2 or FeCl2. Either one of these is acceptable. No, Drew, doesn't work like that, Bubby. Sorry. I'm glad you erased all of that. That would have been fine, Drew. All right, last but not least. Ooh. Oh, no, sorry. I went through the rip. D, how many liters of chlorine measured at 25 degrees, 750 milliliters of mercury are produced when cells operate as described in part B? PV equals nRT. Here, I'll do it over here. Yes, we love PV equals nRT, and don't you talk bad about PV equals nRT. So we're looking for the volume. What's the matter? Yeah, 750. It's true. So our moles, 0.009. What was it? Okay. Okay, so here we go. We have iron and chlorine. How many of these do we have? One. How many of these do we have? One. I get you. You're good. You're thinking. 933 or whatever's in my calculator. The pressure is 750 millimeters of mercury, so I'm going to use good old Tor. 6236. Is that right? Okay. Liter, mole, Kelvin, and then 298 since we're at 25 degrees. So I type all that fun in. Oh, I didn't type all that fun in. What's man-made? What is? Huh? Of who? 0.231?
Yeah, I got that.
Let's go. All right. So there is part D. Okay. Part E. Calculate the current that would produce chlorine gas at a rate of 3 grams per hour. Don't forget, what else do we have? Amps. So 3 grams per hour. Got it. Got it. So we're going to start off with what? Grams. So 3 grams of chlorine, 1 mole of chlorine, 2 times 35.45, and 1 mole of chlorine. How many electrons? 2. One for each chlorine. Chlorine, 2 electrons. Let's go a little Coulombic action here. So 96,485 amp seconds. Wait, check. Put it on the other side. Grr. I want mole of electrons on the bottom. 96,485 amp seconds. Mole of electrons. And then that gives us a number. Let's see what that number is. 3
hours in this.
We'll get to that here in a second. 96,485 divided by 2 times 35.45. Don't pack up yet. I got it. 8165.16, and that is amp seconds. What do I do? Divide by 3,600 seconds. And whatever that equals, 2.27 amps. Let's go. All right, so test tomorrow. I'll have these 2 videos up later on today. So if you need to watch that again, have a great day, guys. Yeah. What you got?
So with